Hello friends.
My name is Jalal. This is another build for the Mostly Printed CNC machine. This machine is designed by Ryan Ziller. He has an official website. You will find the full details and the information about the machine and its part in that website. Also, you will find the forums for the support by the designer himself and other community around our machine. Also in the website you will find other products like a low rider, the bigger brother for this machine. Also in the website you will find the store page where you can buy the 3D printed part or the electronic kits or the mechanical kits from there. As in the title of this video, we will talk about this machine and what you need to know before you build your own machine. I will show you first some examples of the application you can do with this machine, so you will have a wider view. Here the first example is the main usage for this machine, as the name say, CNC machine. So you can milling a wood or other materials with this machine. I'll show you another example for milling. This example is also but the material here is a sheet of aluminum. Also the machine is doing very well. We have another example for the metal materials. Here the title is saying it's milling in steel, and the machine also doing very well. We have another usage for the machine. Also the user here attached some laser diode to the gantry, and the machine is working as a laser engraver or a laser cutter. We will have another example here. The user attached some pen to the gantry, and the machine is working as a plotter or a drawing machine. Here is another example for the drawing. As you see, just attach a pen to the gantry and the machine is working just like a normal plotter. For the G-code, the command set by electronics, we will find it later in coming videos. Also, here we find the user attached some new invention in this community. It's called a needle cutter. Some motors, high-speed rotation motors with a needle attached to it, and it's used to cut the foams on soft materials like it. Here we see that they attached some 3D printing head to the gantry, of course with some build plate. It's worked as a 3D printer, a normal 3D printer. Here in this design, the designer Ryan himself attached 4 head of 3D printing to one machine, and it's a very genius solution to do continuous jobs like this. He attached a plasma cutter to the gantry, and he is cutting the steel smoothly like everything the machine is doing. Now we will talk about what we need to build a mostly printed CNC machine. In the official website, under the branch of Mostly Printed CNC or the MPCNC, you will find the whole details you need to build it. We will start in the assembly page for the first item you need to know about it. We will start here in the conduits. Before we go further in the details, you have to decide what you are going to do with the machine. The build size is very important to know first you build your own. For the dimensions and exact length of the conduit and other parts, we have to go to the cut calculator. This page, of course, you have in two systems, in metrics or imperial. I will go to the metric. In this page, just you have to input the required workspace, and the calculator gives you the exact length of everything. For me, I need about 1200 millimeter in the X and Y, and about 270 on the Z axis. Of course, it's really big. The designer don't recommend these dimensions, but for me, I think I will have no problem with that. The central section or the gantry will just have to carry the laser diode, so there is no weight on. As I said, you just put the required workspace, and the calculator gives you the exact length for the X and Y and Z, for the legs and the lead screw, and the tables and minimum length of the belts. Everything you have here in details. The other important thing about the conduit is the outer diameter. The MPCNC have 3 sets of 3D printed parts. Every set is suitable for outer diameter. The second element in the build is the 3D printed part. The 3D printed part, you can have them in Thingiverse website. The designer has a username altered on under that platform. Of course, as we said, the MPCNC have 3 sets. Every set is suitable for an outer diameter. Here we have the 25 millimeter outer diameter, and of course we have the links to the other diameters. Be careful before you print the parts. If it's possible, buy the tubes first and measure them manually for the outer diameter, and print the parts suitable to that diameter. We will back to the name of the sets. What we understand from this name. The MPCNC through the time have 3 versions, the V1 and the V2 and the Burley. The Burley is the last version in the time of preparation this video. It has some enhancement and updates in the central section. The F is some code to the 25 millimeter outer diameter. As we see in the thing details, we have 2 other sets. Each one has some letter as a code to it. Here I want to mention something I have been through. My 3D printer is the CR10S, and I'm very happy with it. But every time I'm printing in some new materials, I have sometimes wrong dimensions in the models. So if it's possible, print some parts as a test. I'm recommending to go and print those parts. I will show you my settings on the Cura slicer and how I solved some problems I have. As you see, this is the foot part. When I printed first part, it's come really narrow. The tubes didn't fit inside it. So I searched on the internet and YouTube. I found a very useful video telling that if the models are coming in wrong dimensions or in incorrect dimensions, we have some settings here. The horizontal expansion. The horizontal expansion is giving the walls of the model some offset outside or inside. So for this example, when I'm giving the horizontal expansion a minus value, this hole will come a little wider, so the tubes will fit inside. The F ruler, if you print this part first, you will test it as if the screws go inside the holes perfectly or smoothly or not. Also the Z lower part for the tubes, if it's fit or not, or here we have some place to the bearing. Also you can find if it's fit or not. The designer has give some settings for the printing. For each part, the infill. Beside the infill, he gives you some approximately time for the printing and weight. In total, as you see, you will print the all parts in about 120 hours and a total of 2 kilograms of PLA. The third item I want to talk about is the hardware part. For the hardware, it's not very hard to find them in the local market. For me, I did that. I print this list and went to the nearest hardware store and find everything here. The fourth element I want to mention is the stepper motors. As you see in the official website store, they recommending the NEMA 17 with 76 ounce per inch. I couldn't buy it from the official website. In the local market also I couldn't find enough information. After not long searching in the internet, I found a good deal on AliExpress. I think it's enough for the moving of this machine. I have this kit of 5 stepper motors. Of course you need 5 of them for the machine. About the stepper motors, the NEMA 17 has a fixed dimension for the width and length. About 42 millimeters. The only difference is the height. The height here is determined the strength of the motor. So longest height is strongest motor. For this kit, the height is 48 millimeter. Ignore this 74. I don't know what it is. But the height is 48 and it gives, as they say, it gives 78 ounces per inch, and I think it's enough. with the current 1.7 ampere. I think there is a relationship to the torque strength also related to the ampere, but I really don't know what it is. For now, I think it's enough for what we are going to do with it. The fifth element is the electronic parts. Of course, you will find the list in the official website. Here I want to talk especially about the boards, the control boards. The designer is preferring to work with Marlin firmware. You also can control the machine through the GRBL or Gerbil firmware. I will go with the Marlin firmware and suitable boards for that. You can buy the set from the store of the official website, or he will send you the mini Rambo board or the Rambo board. Both of them, as we said, is suitable for Marlin firmware. You also can go to another option with the Rams board. As we here see the mini Rambo board. Here is the Rams. The Rams 1.4 is a very common board to controlling CNC and 3D printers or the DIY kits. Beside the Rams, which is controlling or holding the drivers, the stepper motor drivers, you need the Arduino Mega board, which you will load the firmware to the Arduino Mega and attach the Rams board to the Arduino Mega, and later attaching the stepper motor drivers to the Rams board. Of course, we will talk about that in details in the assembling videos. Beside the controlling on the board, you will need some power supply, any kind of power supply with 12 volt and minimum 6 ampere. Also for the motion parts, you will need some belts, some pulleys, bearing. Of course, we talked about the Niva 70s. You need some wiring. The designer has prepared some wiring kits. You can buy them from the store, or you can go with standard wiring and do the wire. I saw many of videos using the Cat5 networking or the Cat6 networking cables to wire the machine. Also, you need some spindles or laser modules or a needle cutter. It depends what you want to do with the machine. I also want to mention the table and the space where you want to operate the machine in it. For me, I need to prepare something to get rid of the smoke and of the vapors which came from the laser cutting. Also the table, it will be a really big build. For the table, it's happened that I have two pieces of MDF. They were two doors of an old cabinet. I bought the legs and the supporting bridge from a local store here. Obviously, I don't have this woodworking experience, but what it really matters here is to provide enough space for the machine to work in low noise and low vibrations. Really, this is what it matters. I'm going to finish the video here. I'm sorry if it's boring or it seems a newbie. If you want to continue this journey with me, please subscribe And if you have a comment or any questions, leave it in the comments, and I will answer as fast as possible. Thank you. Goodbye.